Welcome back to Demolition Worker. Today we leave airplanes behind to tackle a massive, truly terrifying piece of space engineering. You are looking at a massive retired orbital rocket booster. This colossal machine once generated millions of pounds of pure thrust. The blackened exterior tells a brutal story of extreme atmospheric re-entry. Normal aluminum would have melted completely during this harsh journey. Instead of standard metal, engineers built this beast using advanced aluminum lithium alloys wrapped tightly in high-density carbon fiber. These exotic materials provided incredible strength while keeping the total weight incredibly low for the demanding journey into outer space. However, the extreme heat from the rocket engine completely altered the internal metal structure, making it unbelievably hard and rigid. Standard cutting tools are completely useless against this hardened shell. We need something much more powerful to break it down entirely. Enter the industrial plasma cutter. We have mounted this incredibly powerful thermal weapon directly onto a heavy-duty excavator robotic arm. This robotic setup allows us to maintain a safe distance while slicing through the dangerous, thick layers of aerospace-grade metal. We are specifically targeting the massive engine nozzles today. They are constructed from solid titanium that is exactly 10 centimeters thick. Watch closely as the bright blue plasma arc ignites. The sheer temperature of this cutting beam is absolutely mind-blowing today. Sparks fly everywhere as the superheated plasma effortlessly pierces through the impenetrable titanium shield of the main rocket engine exhaust nozzle. This is truly the absolute highest level of industrial metal demolition. Every single cut requires perfect precision and total machine control. The bright blue sparks create a mesmerizing light show against the dark, scorched metal of the massive orbital space rocket booster. You can actually see the molten titanium dripping down as the robotic arm slowly moves the plasma cutter across the surface. The sheer scale of this aerospace component is difficult to comprehend until you stand directly next to its massive metallic frame. Each of these structural ribs was designed to withstand the immense crushing forces of a high-speed launch into Earth orbit. Now they are simply scrap metal waiting to be processed. Our massive hydraulic shears will easily snap these smaller support beams. The sound of tearing aerospace-grade aluminum echoes loudly across the demolition yard. It is a symphony of pure industrial destruction. We must carefully separate the carbon fiber from the metal alloys. Mixed materials are extremely difficult to recycle in standard facilities. The carbon fiber composite splinters and cracks under the immense pressure of our heavy machinery. It releases fine clouds of dust. Our operators wear specialized respiratory protection to avoid inhaling these dangerous microscopic fibers during the intense mechanical dismantling process out here. Look at the intricate plumbing surrounding the main combustion chamber. Liquid oxygen once flowed through these highly pressurized stainless steel pipes. We use hydraulic rotary cutters to quickly sever these intricate fuel lines. The process is remarkably fast and incredibly highly efficient. The main thrust structure is heavily reinforced. We will need to bring in the larger excavator to pull this section apart. The ground literally shakes as the massive steel jaws clamp down on the thick aerospace bulkhead. The immense power is terrifying. Slowly but surely, the incredibly tough aluminum lithium alloy begins to yield. It bends and tears under the relentless hydraulic pressure. This specific alloy was originally developed to save weight without sacrificing structural integrity. It is highly valued in the recycling industry. Once melted down, this premium metal will likely find a new life in future aviation projects or advanced commercial automotive manufacturing. The plasma cutter continues its slow, methodical journey around the circumference of the massive titanium engine bell. The heat is intense. We have to constantly monitor the temperature of the cutting equipment. Overheating could easily destroy the expensive plasma torch nozzle components. A steady stream of compressed air blows away the molten slag, leaving a surprisingly clean cut through the incredibly thick titanium. The vibrant blue glow of the plasma arc illuminates the dark interior of the combustion chamber, revealing complex internal cooling channels. These tiny channels once circulated super-chilled rocket fuel to prevent the engine from melting itself during the intense orbital launch sequence. Now, the plasma cutter easily destroys these delicate structures. The contrast between precision engineering and brutal demolition is truly fascinating today. A massive chunk of the titanium nozzle finally breaks free. It crashes onto the concrete floor with a deafening, heavy thud. That single piece of scrap metal weighs over 2,000 pounds. We will use a heavy-duty electromagnet to move it. The excavator operator skillfully maneuvers the powerful magnet into position. It securely grabs the heavy titanium block with absolute magnetic ease. We carefully load these valuable titanium chunks into a reinforced steel transport bin. They will be shipped to a specialized foundry. Titanium recycling is a highly lucrative business. This metal retains its incredible strength and desirable properties even after being completely remelted. We are now moving towards the upper section of the booster. This area contains the complex avionics and guidance control systems. Most of the sensitive electronic components were removed before the booster arrived at our yard. We are left with empty housings. These equipment racks are made from lightweight magnesium alloys. They are incredibly brittle and shatter easily under the heavy excavator tracks. We crush these fragile frames to maximize the space inside our transport containers. Efficiency is absolutely crucial in the demolition business. The sheer volume of material we are processing today is staggering. This single rocket booster will fill several large transport trucks. Every piece of metal is meticulously sorted and categorized. We maximize our profit by ensuring nothing valuable is ever thrown away. The robotic arm adjusts its angle to tackle a particularly stubborn weld. The original aerospace engineers built this machine to last. They never intended for it to be torn apart like this, but every machine eventually reaches the end of its lifespan. The plasma cutter effortlessly slices through the heavy structural weld. A shower of brilliant golden sparks cascades down onto the concrete. We are making excellent progress. More than half of the massive cylindrical hull has already been reduced to manageable scrap pieces. The heavy-duty shears return to bite into the remaining carbon fiber composite panels. The loud crunching sound is incredibly satisfying. We have to carefully manage the massive piles of debris accumulating around the main work area to maintain strict safety standards. A secondary loader continuously clears the workspace, scooping up smaller fragments and dumping them directly into the waiting industrial sorting bins. The coordination between the heavy machines is a beautiful mechanical dance. Our experienced operators know exactly how to work together seamlessly. We are finally approaching the massive structural thrust ring. This is the absolute strongest part of the entire orbital rocket booster. It is forged from a single massive piece of high-strength aerospace aluminum. The plasma cutter will struggle with this thickness. We switch the robotic arm attachment. We are bringing out the ultra-high-pressure abrasive water jet cutter for this section. The water jet slices through the thick aluminum ring using a concentrated stream of water mixed with sharp garnet abrasive particles. It is a slower process than the plasma cutter, but it easily handles incredibly thick materials without creating a heat-affected zone. The precision of the water jet is absolutely remarkable. It leaves a perfectly smooth edge on the incredibly thick aluminum block. With the main thrust ring successfully divided, the structural integrity of the remaining booster section is completely and utterly compromised now. The heavy excavator easily pushes the remaining cylindrical structure over. It collapses onto the ground with a massive, earth-shaking crash. Now that it is on the ground, the final dismantling process will be much faster and significantly safer for our team. The hydraulic shears tear into the collapsed hull like a giant mechanical predator. The aerospace aluminum offers absolutely no meaningful resistance. We are ripping the remaining carbon fiber panels away from the internal aluminum framework. The separation process is becoming much easier. Huge sheets of curved metal are tossed into the processing pile. They look like the shed skin of a massive mechanical beast. The sheer power of these hydraulic demolition machines never ceases to amaze. They turn indestructible aerospace engineering into simple scrap. We are carefully inspecting the remaining engine components. Some of these intricate titanium valves might actually be valuable to private collectors. The space memorabilia market is surprisingly lucrative. We often find buyers who want a piece of genuine, flown space exploration history. However, the vast majority of this material is destined for the melting furnace. It will be completely reborn as new products. The plasma cutter is brought back to finish off the remaining titanium engine bells. The mesmerizing blue sparks fill the air. Cutting titanium requires incredible patience. If you move the plasma torch too quickly, the intense arc will fail to penetrate completely. Our robotic arm ensures a perfectly consistent cutting speed. This eliminates human error and maximizes the efficiency of the demolition process. The final piece of the massive engine nozzle drops to the floor. The most difficult part of today's job is done. We have successfully conquered the 10-centimeter thick titanium challenge. This truly proves the incredible capability of our industrial cutting equipment. The yard is now completely filled with sorted piles of exotic aerospace materials. The sheer volume of recycled metal is impressive. We have separate mountains of premium aluminum lithium alloy, high-density carbon fiber composite, and incredibly valuable aerospace-grade solid titanium. A fleet of heavy transport trucks is already arriving to carry these valuable materials away to specialized industrial recycling facilities nationwide. The massive loader quickly fills the first truck with aluminum scrap. The heavy metal pieces crash loudly into the steel trailer. It takes less than 10 minutes to completely load 20 tons of processed aerospace aluminum. Our logistics operation is highly efficient. The titanium requires special handling. We carefully load the heavy chunks onto flatbed trailers using the powerful industrial electromagnetic lifting crane. These titanium blocks are incredibly dense and heavy. We must properly secure them to ensure safe transportation on the public highways. The carbon fiber debris is packed into specialized sealed containers. This prevents the dangerous microscopic fibers from escaping into the environment. Environmental safety is a top priority in modern industrial demolition. We strictly follow all regulations regarding the handling of composite materials. As the last truck drives away, the demolition yard suddenly feels strangely empty. The colossal rocket booster has completely vanished today. We have successfully transformed a massive piece of space exploration history into raw materials ready for the next generation of manufacturing. This project pushed our heavy machinery and our skilled operators to their absolute limits. It was an incredibly demanding demolition job. Tackling the heat-hardened aerospace alloys and the massive titanium engine components required specialized equipment and highly advanced thermal cutting techniques. We proved that no machine, no matter how advanced or heavily armored, can resist the relentless power of modern industrial demolition. The combination of heavy hydraulic shears and robotic plasma cutting technology is the ultimate solution for extreme heavy-duty metal recycling. We are incredibly proud of the clean, efficient, and highly safe manner in which our team executed this complex dismantling operation. Taking apart a used orbital space rocket booster is definitely one of the most exciting and challenging projects we have undertaken. It perfectly demonstrates the absolute highest level of the metal demolition industry. This requires immense power, perfect precision, and deep knowledge. We hope you enjoyed watching this incredible process of industrial destruction as much as we enjoyed tearing this massive beast apart. We will continue to find the biggest, toughest, and most interesting machines on the planet to break down for your entertainment. Make sure to subscribe so you never miss an episode of our extreme heavy-duty industrial demolition and metal recycling adventures. Thank you for watching Demolition Worker. Stay safe out there, and we will see you next time for another massive teardown.